Hello, we are Team Aggie still from North Carolina A&T, and for this competition, our process began with the open ideation stage. So every team member brought different concepts to the table, ranging from simple tools to more complex mechanical assemblies. Our goal was to find a design that kind of balanced the functional utility with specific strengths and limitations of 3D printing. Our first design concept started as a multifunctional hammer. We started with refining the geometry on Onshape and Fusion, but once we moved into the 3D printing stage, we encountered significant issues. So one of the biggest things was the internal components were fused together, causing the tool to be completely static and not be able to move. Additionally, the hammer was positioned at an awkward angle that made it unusable. So we kind of realized that we had to scrap the layout and rethink the mechanical design. So because of the issues with our first design, we decided to go for a new design that was more inspired by the standard pliers. So this style definitely gave us more fluid movement that we were looking for. And initially, printing our prototypes in PLA plastic was a complete success. Everything fit together perfectly, and the mechanisms worked exactly how we wanted it. But things got much harder once we switched over to the metal filament. So we actually realized that our printer settings were miscalculated for the metal, which caused the nozzle to stop releasing the material correctly. It led to a failed print where the parts just did not come out together at all. So to fix this, we actually used a pre-existing block setting that we knew worked with the metal printer's tolerances, which finally got us a high quality print. So going on to the final stage, which is the firing process. During the heat treatment, we actually found out that too much oxygen was getting into the crucible. This caused the metal to also rust and become brittle, which ultimately made the whole component break. This was definitely a setback for me and my team, but we are continuing the process by finding better ways to manage the air inside the furnace, and we're also still testing and refining our post-processing to get the durability we need. Thank you.